Hello, I'm Frank Conkling with Panda Consulting, and this is Panda Consulting's ArcGIS workshop. We're going to do something a little bit different today. We're going to really talk about some basic concepts. I recently was at a surveyor conference, and during the conference, I got into a discussion, rather heated discussion, with somebody about CAD versus GIS. And their point was that CAD is so much more accurate than GIS. And I started questioning, well, what do you mean by accurate? He said, yeah, I can take a traverse and it can close, and I know it's a good closure, so it's more accurate. And I started talking about it. It's like, well, do you understand really the multiple ways that you can evaluate accuracy? And it got me thinking that this might be a good topic for us to at least bring up. There won't be a whole lot of technology, but it will be about these concepts. So hopefully you enjoy this. It may not be as long as some of our other sessions, but like I said, hopefully you enjoy it. Just a quick reminder, uh, the at the lower right corner, you'll see the UR code, the QR code, which will get you to the Panic Consulting website and show you and tell you who we are, what we do, why we do it, how we do it. Also, a reminder that Panic Consulting is an ESRI business partner, have been for over 25 years. And we are the first business partner in the nation to get the parcel management specialty designation, including with our release ready and our state and local government designations. So let's start. Let's start with this discussion. So the first discussion I want to have is that this concept of accuracy and precision. And let's start with this in that accuracy really means how close a measurement comes to its true value. What is the true value here? While precision really talks about how consistently something is measured or how fine a measurement you actually provide here. And here's some great examples of this in that if we look at this on the very left side here, we see a target. And in that target, you see a series of measurements or observations if you're surveying. And these observations are very close to one another. But in the reality, if this is actually an accurate representation, and that bullseye is where should the true value is on here, that even though these are very precise, they are not accurate. It just means that you could measure that again and again and again and again, or it had a very high level of precision on there, but it does not mean it's accurate. The next one over has some better accuracy on here. It's closer to the true value. It's closer to hitting that bullseye, but it's scattered quite a bit, and there's about quite a bit of randomness in there. So if you were looking for precision, you probably failed at that point. But if you were looking for accuracy, it got you closer to accuracy than that first single set of values did. If we go over the third from the left, we see this is purely random in here as far as random observations and such. It's neither precise, meaning it's not very well clustered together, and it's not accurate at all because again, these observations are well outside what we consider allowable in here. And finally, we get to all the way on the right-hand side, and we see that these observations, these measurements are both precise and they're accurate. And I want you to think about that when you're telling somebody, I have accurate parcels. What do you really mean with that? All right. So what we're going to do is look a little bit more. And this is a real good example of this. Inside, inside of GIS, we have a tool in which we can take a series of courses that are provided to us, a legal description, for example. in which they have bearings and distances, and they provide us with those bearings and distances. And we can take those and input them in. And what this really is doing is actually measuring how far each of these, and I'm going to call them observations because I am a surveyor, how far each of these observations took us away from this beginning point, how far to the east, how far to the north, how far to the east, how far to the north, how far south, how far west. All of these different points in here can be thought of as those different observations. And there's an accumulation that occurs so that this departures and these latitudes, as they're called inside surveying, if they come back and they add up to the close one, that means that in fact you have got a closed traverse or one which falls within your tolerance. That doesn't mean that these measurements that are written down are accurate measurements. It's just so that this misclosure distance report that you get out of a traverse and then misclosure ratio, these are measurements of precision, not accuracy, measurements of precision. And often when I talk to people about this, their constant discussion is, oh, this is very accurate because this gives me a good closure and it's a good accuracy. It's not. It is a good precision, but it is not a good accuracy. By the way, this misclosure ratio at the bottom here, what this actually is this is the misclosure distance divided by the total traverse perimeter. So if you add up all of the distances traveled, and then you use that to divide this misclosure distance or the distance that it failed to meet and get back to the place that it started at. And this, by the way, is a closed traverse. That's what this is, meaning you would have 1 foot in 2,000 feet. And that's the way we as surveyors measured how precise our traverses or our observations are. So that normally what you'll find in surveying is you'll find that if you're going and measuring rural properties, you might have a precision level of 1 to 20,000 or even 1 to 40,000 if you had a good one, meaning you were very precise in what you did. Matter of fact, with the ArcGIS Pro Traverse tool, the highest precision level that you can get, the highest ratio is 1 to 100,000. That's the highest they'll actually report it, only because of anything above that is really not used to, it's useless on here whatsoever. And I want you to remember here that what you're seeing on this is that these measurements that are put in here, whether it's the curves or whether it's the distances in here, these are all rounded. They are not actually very precise. They are all rounded, usually to the closest hundredth of a foot. And the actual bearings, the direction information that you're given, is also being rounded to the closest full section, excuse me, the closest full second of arc on here. So the closest full section of arc and the closest hundredth here, there's rounding. And what you're seeing here is as much a result of that accumulation of rounding error as it is anything else. If you were to go and measure these out or have provided a more precise distance and a more precise angle or direction, you would probably get even closer than this. But because these are rounded, this misclosure distance that you're being provided really is not how accurate you are, but how precise your measurements are and how well they'll get you to where you want to be. So then the question is, and that's precision versus accuracy. So the question is, well, if that's the case, what is accuracy? And I break it down into 5 really pillars. These are the ways that you can define accuracy. And we're going to talk a little bit about each of them. The first one is geometric accuracy. This one is kind of easy. And this is how well can does this does this geometry that we're calculating through these courses or whatever, how well does that accurately represent the actual shape of a parcel? The next one after that is geographic accuracy. This builds it out from just, oh, that shape, but where is that shape? Where being, is it located in a certain projection system? Is it not in a projection system? How does it relate to other things on there? That brings us into topologic accuracy. Topologic accuracy is that relationship. How do these things relate to others that are associated with it, that are supposed to be close to it? Again, it comes down to isolated components, components in a larger group, the relationships between those components, and then we come down to a whole nother set of accuracy that rarely gets talked about, and that's attribute accuracy. Attribute is how complete is the attribution associated with a single parcel with your data? How good is that accuracy on there? And where have you got problems with it? And then finally, this is one that's really interesting is temporal accuracy. How current, how up to date is this data? If you only do it once a year, well, you don't have very good accuracy then because there's going to be multiple changes in there. How well is it and how well does it relate to the current moment? Because all of our data is nothing more than snapshots in time. All right, let's talk about this a little bit more. And in order to go in and do this, I'm going to go and show you a couple of examples using an area on here. So this geometric accuracy. And again, we're going to use this concept of a precision in shape and dimensions. How well does it reflect that area that we're actually going to? So I'm going to pull up and go into ArcGIS Pro for a little bit and show you this is a survey, a copy of a survey for a couple of parcels that are getting split. And it gives us the standard types of information that we have, bearing and distances, some curve information in here, coming all the way around on here. And if we were to go and look at the curve information in here, let's go and do it this way. Curves information here. If we were to go and look at this curve information on here, I guess I'll do it this way. Um, our curve information here. All right. How well and how is that reported back to us? Again, one of the things you're going to see, and one thing once you start thinking about this a little bit, well, you have to think about what am I actually being told here? Is that the actual distance or measurement, or is this some sort of rounding it so that it's something that's useful for the normal person? Okay. So so this is the geometry on here. And let's look at what's actually in here as far as the the data that we have accumulated on here. This is the actual information. And if I go in and put my labels on here, it's telling me a little bit more about what is mapped here. These are just sort of standard labels as far as what information is stored on the lines. Real quickly, before I do anything else, if I look at this demo of the actual information here and turn these things off, I note a couple things. One, this in here is supposed to be a curve. This in here is supposed to be a curve. One long curve that's split into two different components. And then this in here is also supposed to be a curve. But if I look at the actual parcels as they're drawn, I can see, well, wait a minute. These are curves. That has valid information on here. But in here, this is drawn as a series of straight lines in here. So I can immediately say that the parcels as they exist do not accurately reflect the geometry. Before I even get into any measurements or anything else, I can say they do not reflect the geometry of this parcel. Again, straight line, curves, straight line. That's supposed to be a curve on my demo here. That should be a curve on here. So immediately I can start looking at that from a geometric standpoint. This is not very well um, go and mapped on here. All right, let's go here and let's go back here to this. So there's a couple techniques that often are used on here and to go and validate what the geometry is on here using COGO, coordinate geometry. And that's how you can go and a tool that we use every day when we're actually parcel mapping inside of GIS. It's a way of calculating where the endpoints of the lines are by using standard trigonometric functions, sines, cosines. It really breaks it down and tells us how far over and up these things are. The GPS validation is something that often we'll do as a surveyor, not as applicable here, but it is something that we want to look at. Let's look at this and see if we go and actually apply some COGO components on here. I actually have a traverse that I want to be looking at here, in which I've gone and input some of these values. If I go to traverse and go to my construction line, I actually have stored it out and I can import that traverse file here. And when I import it, I can see that, in fact, I have got all the information that's included on this demo JPEG for me. And I can include all of that in here. If I can turn off this, I can see a little bit more. So on here, for example, I can see I'm using the same bearing on here. I'm putting the 115.00 in here, and I'm using the 115.00 for the recorded. Let's explore this a little bit more, because if I look at this, often what happens is that from a surveying standpoint, we have a record distance. This is what the legal document or the legal description of this parcel says. But when the actual surveyor went out and measured between the monuments that they found, a point here and a point here, they calculated that it wasn't, in fact, 115.00, it was 115.16 feet. So immediately you start seeing some discrepancies creeping in here. Does that mean that this is a not accurate survey? No, it means that it's even more accurate because it's telling you some of the surveyor's findings. And this is completely common inside of here, and I'll show you as we get into some of the other pillars how you take care of that or how you should be taking care of that, both with how the parcel fabric does and how I think you really should be doing it from this point forward. But this is a common occurrence where a legal description goes and tells us that these 2 points are approximately, and I want to make sure that you understand, all legal descriptions are approximate because the boundary is defined by the location of the monuments. So that it's approximately 115.00 feet apart, but we've actually gone and measured or calculated 115.16 feet. Same way as we move along here, we'll start seeing that in fact, this is the next bearing and distance on this point, and the record information says 103.27 feet, but the actual calculation is 103.38 feet. So again, a challenge when we're talking about accuracy. What is it that we're really attempting to see? Is it accurate as it's relative to the record information? There's probably some variance in there because, again, legal descriptions always have this approximation of where those boundary monuments can be found, but it probably is a fairly good representation of where these corners are that are out there. but you can also already see there's some areas in here. So if we again say, well, maybe then this whole misclosure distance, maybe we should be showing our calc instead of our recorded. But then we run into other problems on here, and that, well, what about the acreage then? Because if we use the calculated distance, that's going to give us a different set of information than when we use the recorded information. So there is this plasticity within the parcels because of this whole ambiguity of where a monument's located versus what appears of the actual record information. So let's go into show on these construction lines again. So I ran this out, and in fact, I've got it. It's a fairly good approximation of where it is. The other element we have is that if I see here that I start at this point here, and I input these bearings and distances exactly as they're put in here, and in this case, I'm using the 2.7, I'm using recorded, I'm using the 115 here, recorded. But if I go up here to this very end here, I'll see that this point, as shown, does not necessarily reflect exactly where the other point is, both in our survey description and in the actual mapping beforehand, because of how that's georeferenced. What could that be caused by? It's definitely not a rounding error here. Rather, it's a difference or a rounding error in our direction, or it could be that the bearings as derived on the survey use a slightly different basis of bearing than what's actually stored inside of our information. So there's this other rotation that we have to be concerned about is that if we're really thinking about accuracy, is the geometry the overall accurate geometry? And is it exactly what we've got in our existing data? It isn't. All right, so the geometric accuracy, again, is how well does it reflect the overall shape and dimensions of what we're actually mapping out there, whether it's on a projection or not. Just that actual shape, how well does it do that on here? And this, by the way, is often what people think of as just accurate. Oh, if it reflects the geometry, it's completely accurate. But then we get into other components. Where in the world is this? All right. Is this in fact in alignment with real world locations? Is this spatially enabled? Is it spatially shown? And this is where CAD often falls down when you get CAD from somebody else, is that sometimes they will in fact put a spatial reference on their CAD file, but oftentimes they won't. Oftentimes they'll either just use 10,000, 10,000, or they'll just give you a CAD file that does not have any sort of projection information on it because they are using a flat sheet of paper. They are not actually taking into account the fact that the Earth is not flat. In fact, it is an orb on here. All right, so if we look at this spatial alignment component on here, then we get into other elements in here. For example, how well does it actually go and align in here? Is it relative to other features inside of this same projection system? How precise is that projection system? It's one of the things that often when I talk to people who are just getting familiar with GIS, when you start looking at different projection systems, you start recognizing that they have different precision levels. Let's start with this, that all projections have distortion because you're trying to take information that's measured on the ground and move it to some sort of a projection that's an approximation of a surface. And that projection can be distorted in its orientation, its size, its direction, its distances, the overall area. So once you start talking about projections, you start recognizing there's some sort of distortion that always occurs in it. So question is geographic accuracy still something that we should be attaining to? Yes, we should be looking at making sure that our information is accurately placed on some sort of datum, some sort of projection that's well established and is precise enough for us to actually go and utilize. Often some techniques to just sort of figure out where they are, things like georeferencing, where you take one thing and say that these points go here and let it actually take that flat object and distort it slightly to take into account the information associated with your projection information. Often things like satellite imagery overlays will give you an approximation of sort of how these things are located geographically. And things like putting a base map in here will tell us often how well it is. Some of the problems we have with parcels is that you rarely see any identifiable elements on a photo that's associated with the ownership of the land. So identifying photo identifiables and saying that's exactly where that point or that corner should be is very difficult. I would somewhat with my tongue firmly in my cheek, I can tell you that having surveyed outside for 40 years, I have not ever come across a property line out there drawn on the ground so I can say that's the property line. It's this confluence of abstraction and physical elements that kind of makes parcel mapping really, really difficult. All right, geographic accuracy. This is where you start moving from CAD into GIS and you start recognizing that with geographic accuracy, you can start looking at relationships. You can start looking at how things are related to one another, where they are in relationship to one another, which brings up topologic accuracy. Topologic accuracy is the spatial relationships and connectivity between parcels. If we have parcels on the same layer that are not contiguous with one another, or they are overlapping, or they have gaps, or they have vertical topologic issues where you've got layers that aren't on the same accuracy as far as projections, then you start having issues when you start trying to deal with the relationships between those. Is a parcel located inside of a subdivision? How much of a single parcel is contained within a certain flood zone? Luckily for most of us, these other layers of information that we're attempting to do this analysis against are of much lower quality than our parcels, but it's still, we have to recognize that the difference in accuracy between these layers become problematic for us. And the way we often go and look at these are things like topology rules and error detection tools. And inside, for example, the parcel fabric will have topology, but we'll also have things like this tool to go and help highlight gaps and overlaps both within a single layer and between layers as we go and do this. So this is just within a single layer, and this is between layers here on here. So topologic accuracy, how well does it relate to the other things around it? Again, a whole nother pillar of accuracy that we often overlook when we're dealing with somebody saying, well, how accurate is your data? And by the way, one of those problems that we come into is when, in fact, we start failing to meet the accuracy level on one of the pillars, and it starts rippling through as we go down. I can tell you this data set has some of those issues because it has information stored in here where curves were not stored as true geometric curves. Instead, they were stored as approximations, which is often some of the things that we would attempt to do to try to make it easier, saying that a lower level of accuracy is acceptable only because we didn't want to spend the time to fix them, or that's the level of accuracy for the data that we're actually acquiring or was given to us, so that we didn't want to fix the geometry on here, so that we're willing to accept that lower level and still say, okay, that's acceptable for what I'm doing on here. Again, as we start thinking about accuracy and our parcels, we want to be thinking about all of these things. And I think you can begin to understand one of my components here is that we want to be very careful when we say that we have accurate parcels, because I challenge anybody. I don't think anybody has accurate parcels. We always have issues with them. All right, so topologic relationships, again, they can be related to our geometric accuracy. They can be related to our geographic accuracy. If we don't have good geometry, we don't have good geographic locations of these things. When we start analyzing relationships, which is our topologic accuracy, that's when we start having problems between these on here. We start failing because we start attempting to deal with some of this ambiguity between here. The next level of accuracy that I want to talk about is one in which we can call it attribute accuracy. This is the fourth pillar of accuracy that we're going to deal with. And that this actually has to define not just the spatial relationships and accuracy, but how well is this information actually represented, not the geometry, but what it is. Up until then, we've been talking about what the shape is, where it is. Now we want to start talking about what this thing is. And that's when we start running into issues. And I'm going to go and turn off some of these others layers here and start talking about this. So on here, I said, if I really want to go and represent the survey, to go and use that to create my parcel, I have to make sure that I'm going and recording everything off of here, that anything that might have an influence on here. For example, on this bearing that goes from this corner to this corner here, I can see that they've given me the bearing information on here, which I've gone and stored as this. But then they're also giving me this information that in fact this is 103.27 feet is the record information. And 103.38 feet is the calc information. So I'm now making a decision, which of these am I going to use to more accurately reflect what the size and shape and position of this is. And you'll note what I've done is I've actually noted the record information, because that's often what the general public is going to be looking at. But perhaps it might be better to go and represent this with the count that would give me a higher precision level on my tolerance. If I actually look at my structure, my actual layer structure, and what attributes I have inside of my parcel layers within the parcel fabric, I can find that, in fact, I have an attribute field called Kogo type. That Kogo type allows me to go and determine the information that's stored on there. Where did that information come from? Or to go and tell it using that same lexicon that I was just talking about. This entered value is the one that I could think of as being, this is the record information. This is what appears on the official records in the clerk's office. This is what the survey said on here. Well, this geometry could in fact be a result of what I sort of calculated this to be. All right. And that's also shown on here. And then finally, this computed within surveying, we have not just the record information, not just the measured information, but also a calculated. So this could be the measured one on here. The deficiency on here on even the parcel fabric, because again, we're trying to store one set of information on here. My suggestion is that maybe if we really want to do this accurate, we should have three sets of information. One being the record information, one being the calculated information, and one maybe being the measured information or the observed information on here. We want to reflect as much as we can on the data that we're collecting to make sure that it really accurately reflects the findings for that parcel. Now, again, if you don't have a survey, all you can do is reflect what the actual information is on the legal description that's appearing on here. And then also go and if you'll note, one of the things that we do here is we also go and show the shape length in here and tell it, okay, this is also showing the shape length being the mapped or the calculated distances on here. So we're at least going in and putting something in here, but we need to be able to note that there's a difference in some of these lines on here. That's with the lines. Well, what about such as this, the square footage of this parcel? And again, there are inside the parcel fabric, there's some places where we can actually say both, here is the, let's get down here. Here is the square footage as calculated for the acreage on here. Here is the actual calculate. This is this is the legal description of the stated area on here. This is the calculated or mapped acreage on here. And then maybe this is the square footage of there so that we can at least show sort of the variance between all of these and provide a more accurate level of information for anyone who's looking at this data on here to show that within this parcel, there are variances in what's actually being shown on here. By the way, a dirty little secret with surveys is that the surveyor, for the most part, is mapping on the ground. They are not mapping on any sort of grid or projection, but they are providing grid bearings. All right, they are providing grid bearings because often they are using control points which are projected up and using that, but they're using ground distances. So again, there's this ambiguity. They're using grid bearings, ground distances, ground acreages, but when we map it, we're mapping up on a grid. So we're always going to see a difference between the grid acreage or the grid area that's calculated and the actual ground acreage, which is shown here. All right. There's always going to be that difference. So from an accuracy standpoint, we want to make sure that we provide as much of that information. It is complete and it is accurate. There is no attempt to go and fool or provide anything other than the truth on here. Accuracy, attribute accuracy on here is something that you want to go and attempt to get to where you're providing true and correct information wherever you do. Another element on here is whether or not we have, for example, empty attribute fields. Are all the attribute values that are stored in our attribute table, is every field Defined? If it's not defined, why is it not defined? Is there some variance in here? Perhaps we should go and indicate to somebody why, for example, this has a parcel identifier. This has a parcel identifier. This one does not. Why is there not an AFN there? What's the reason for that? Why is there some issue with here? Again, there's things that you want to think about. If somebody goes and takes your information, why are they, what are they seeing? And are they seeing a full and complete record of your data as far as what's on there? You can't be accurate if only half the fields are populated on here. So that's attribute accuracy. Finally, the one that I really want to talk about is this temporal accuracy. How current is your data? When was the last time that this portion of your data was touched? I actually have several clients that every time a change occurs, they actually have an attribute field in there saying, when was the last time that this was updated on here? And they keep track of it. They're religious about it. Now, inside of our data, yes, there are ways that we can look at, for example, if we look at our attribute field here for our parcels, we can go over here and we can see that there is, in fact, modified dates, created dates and modified dates. These are great, but are you going and publishing those to other people that use your data? Or are you just providing them with what you think they think is important? It's interesting. I was at another conference and we had a panel discussion there. We were talking about accuracy. And I had somebody from the general audience go and make a comment that at first I sort of disregarded. And then the more I thought about it, the more I thought that's a real important point. And his point was that speed, meaning how current is the data, speed is the new accuracy. Because if in fact we use the assumption that everything we do, every piece of data that we collect are really nothing more than snapshots in time. How well are we providing information to the consumers of our data, telling us when was this snapshot dated? How long has it been since this thing was touched? And is the information you're looking at the latest and the greatest, or has there been some change on here? And it's as simple as, annual snapshots for parcel data. Well, parcels change every single day. So you should be going and looking for ways to go and provide that most current information to the consumers of your data if you're doing that. Speed is the new accuracy. That's that one pillar that we tend to sort of forget about, but that becomes more and more important as we're looking at some of the uses for our data outside, above and beyond just the property appraiser's office. We've got realtors, we've got everybody looking to see who owns the property. When did that transfer occur? Has there been a change in the overall size of it? Parcel data is getting used in ways that we couldn't even envision 10 years ago. So temporal accuracy. Speed is the new accuracy out here. So the bottom line on here is that be careful when you're claiming that your parcels are accuracy, or when you're talking to somebody about how accurate your parcels are, using it possibly as a sense of pride. Careful with that. Careful with, because I guarantee you not everybody's parcels are accurate. Unless you can fulfill every one of those pillars, unless you're absolutely positive that every one of those pillars, that from a geometry to a geography to a topology to an attribute to the temporal nature of your data, unless you can say every one of those are 100% accurate, please make sure that you make full disclosure. This is how accurate I think this is. This is where I think there are things that we can do better. So, any comments on the workshop? All right. Thank you. Hopefully you enjoyed it. I'm going to stop the recording and please stick around if you're here live. Let's talk about this a little bit more. All right. Thank you.